Let's say we have the following quadratic function. Y equals 1/2 times x minus 4 times x plus 2. This quadratic function is currently in factored form. So how can we graph it when it's in this form? Well, there's a simple three-step process we can use. The first step is we need to find the x-intercepts, which is where this quadratic function or this parabola will actually cross the x-axis. The way that we do that is we take each of the individual parentheses and we set them equal to 0 and we solve for x. Because we can see that if either of these parentheses were equal to 0, this entire right-hand side of the function would be 0. So y would be 0. And when y is equal to 0, that's an x-intercept. So let's go ahead and do that. Let's say x minus 4 is equal to 0, and then x plus 2 is equal to 0. And let's solve for x. So for this one, we can see if we add a 4 to each side, these 4's cancel out. We're left with x is equal to 4. So that's our first x-intercept. And for this one, we can see if we subtract a 2 from each side, these 2's cancel out and we're left with x is equal to negative 2. So our two x-intercepts are where x is equal to 4 and x is equal to negative 2. If we wanted to, we could write them as coordinates like this. When x is 4, y is 0. And when x is negative 2, y is 0. So let's go ahead and plot those x-intercepts on the graph. So the point 4, 0 is 1, 2, 3, 4 right here. And then the point negative 2, 0 is located 1, 2 right here. So these are our x-intercepts. This is where the parabola right here is going to intercept the x-axis. Okay, step 2 is let's find the axis of symmetry. So when we have a parabola, there will always be an axis of symmetry or a line that we can draw down the middle of the parabola to perfectly split it in two. Now, once we've found the two x-intercepts, the axis of symmetry is simply going to be the average value between the two x values. So here we have an x value of 4, and here we have an x value of negative 2. So to find the average between those two values, we can just say negative 2 plus 4, and then we divide them by 2. That will be the average of those values. So we get negative 2 plus 4, that's 2, over 2. 2 divided by 2 is just 1. So the axis of symmetry is located at an x value of 1. Right here. Or if we imagine we could draw a dashed line like this. So this is the line that will perfectly split the parabola in two. The last step is we just need to find the vertex of the parabola. So to do that, we just plug in the value that we just found for the axis of symmetry. We plug that in for x in our original equation, and we just see what we get for y. So let's do that. We get y equals 1/2 times 1 minus 4 times 1 plus 2. So we get 1/2 times 1 minus 4, that's negative 3, and 1 plus 2, that's positive 3. So we get negative 3 times 3, that's negative 9. Negative 9 times 1/2, or half of negative 9, that's negative 4.5, or negative 4.5 if we want to write it as a decimal. So the vertex is located at the point x is 1, y is negative 4.5. So let's write that right here. 1 comma negative 4.5. So let's go ahead and plot that vertex. So at an x value of 1, we go down 4.5. 1, 2, 3, 4, right about here at 5. Now once we have the vertex and the two x-intercepts, we have everything we need to create a rough sketch of what this parabola looks like. We just draw a line that connects all three of those values. So this is roughly what the parabola looks like for the equation y equals 1/2 times x minus 4 times x plus 2. So you can use this simple three-step process to graph any quadratic function that is in factored form.